Hello from Minnesota, where it's really cold right now. As I said on the course website, this is a lot of students' favorite part of this course, where you talk about research design. And one of the things that is relevant to a lot of you all as teachers, which is measurement, and also sampling bias and other kinds of error. So 3 points about tests that you should pick up from the textbook. First, test scores are a combination of true score and error score. Second, reliability is how consistent the test is. And third, validity is whether a test measures what it is supposed to measure. So you could be measuring the wrong thing over and over. What people in test and measurement say is that reliability is a necessary but not sufficient condition for validity. Now, the true score is the true amount of math achievement or self-esteem or whatever else it is that you are measuring. An error can come from a lot of different places. So your total score is the true score, how much of whatever it is you're measuring we really have, and error. Students can guess and they can get a higher score than their true score. They could misread the question or they could accidentally mark in the wrong bubble, and that would decrease their score. They really did know that answer, but they just filled in the wrong thing. The grader could misread their answer. So that can either increase or decrease the score. And then there's just flat out lying. Now, if we're talking about test of achievement, we're assuming that if you knew the answer, you gave the answer. But if we're looking at things like self-esteem or motivation or alcohol use, people don't always tell the truth. So all of those things can increase your error. Sampling, jumping on sampling here, get back to testing, is a a sample is a subset of the population on whom we have data. Probably picked that up in chapter 1. Representative has a very specific meaning to statisticians. I will say representative a lot. A sample is representative if it's similar to the population to which you want to generalize. That's an important key point. If you want to estimate heart disease among retired American teachers from age 65 to 80, then your sample should include a similar distribution to the population of retired teachers. It shouldn't be 30 65-year-olds and then one each person from 66 to 80, because that's not representative. You'd want to include teachers from every state, not just the state of South Dakota, because again, that's not necessarily representative of all American teachers. One thing we see too much of is people generalizing to the population of a country, especially the United States, which is a very big and diverse country, when you only have a sample from one region or one race or age group or occupation. If you're going to generalize to the population of, say, K through 12 students in the United States, then you want to select students from low income, higher income, from different racial groups who maybe have different cultural knowledge. You want to select from different regions of the country, same reason. Sampling bias occurs when you don't have a representative sample. That could be due to a number of reasons. One is self-selection. People generally volunteer studies, people who agree to be in your study. Psychologists have a term, YAVI, young, attractive, verbal, intelligent. Those are people who volunteer for studies, tend to be different on all of those factors. They may be healthier, or they may be in some other way non-representative if you only have volunteers. The example they give in your textbook is if you're asking people about their sex lives, maybe you're going to get the people who volunteer to tell you about that are probably not a random sample. Then there is survivorship bias. People who stay in your study are not representative of the population. So maybe you got a random sample to begin with. Often we see this in education where we're looking at graduation studies. If we look only at the students who were in the school, say, at the beginning of first grade and at the end of sixth grade, and see how many of those had higher self-esteem or whatever it is we're measuring, the kids who were at the school for all 6 years are not necessarily representative if you're in an area that has fairly high turnover. If you're looking at students, changes in students' attitudes from, say, their freshman year to their senior year, again, you're going to miss everybody who dropped out. The textbook has a lot of terms for different kinds of sampling bias, but the main thing we're concerned about is it representative or not? Under coverage, you have some relevant group in the population that's undersampled. Native Americans, for example, are often undersampled because Native Americans tend not to be distributed equally throughout the United States. You have a larger proportion of people in, say, North and South Dakota, less people in Mississippi or Texas. And if you only took a sample from states that didn't include, say, New Mexico, Arizona, North Dakota, South Dakota, you might get a much smaller proportion of Native Americans than you would if you did a larger sample that included, say, every state. If you're assessing students' interest in STEM careers, and often what happens is we exclude students in special ed, we exclude students, say, who are in alternative programs, well, then you're going to get a kind of inaccurate results, maybe, because you're not going to have a true representative sample of your school district population. If you're doing a grant-funded program, or if you're reviewing research for something like an institutional review board, I know Turtle Mountain has an IRB. I think Standing Rock now has an IRB where they're reviewing the research to see if it is valid and reliable and going to be of benefit to the community and fair to the population. In most of those cases, you're going to be asked to justify any inclusion or exclusion criteria for your sample. The last kind of bias we want to consider, up to now, we talked about sampling bias when you're collecting your sample, right? But then in an experimental design, we also want to be clear about bias in selecting for the control group or for the experimental group. We want to assume that the groups that receive the different treatments, say a new versus traditional curriculum, were equivalent at the beginning of the study, and therefore any difference at the end was due to the difference in that curriculum. But we can't be sure about that. Now, we can try to think of every possible variable, reading achievement, math achievement, IQ, motivation, and try to match people on that, and then have equal groups. But we can't think of everything, and that's not always possible to measure their IQ and their reading achievement and their motivation. So what we can do is random assignment. Random assignment reduces the probability that there will be differences between the groups, but it doesn't guarantee it. There's always the possibility that all the best students randomly got assigned to the new treatment group. How likely is that to occur by chance? That is in chapter 7 about the normal distribution, which I'm very excited about.